So good evening to all, and in this session we are going to see another new chapter from pharmaceutical engineering, and that is nothing but the filtration is another important unit operation in your pharmaceuticals. So you might be working in a different pharmaceutical industry. Each and every kind of industry, this filtration is very much important unit operation. Suppose that you are working in the lab, you have synthesized one compound in your chemistry lab. Now you want to purify that, you want to recrystallize that. So in that process, you need a filtration. Suppose that you are working in the bulk drug or API production plant. In that you are using various kind of reactors and various solvents and then solvents and reactant for a synthesis of your API, active pharmaceutical ingredient. Now you have to filter the reaction mixture. So whatever product is there synthesized, or whatever product is being crystallized, so you have to remove the traces of solvents. So for that purpose you need a filtration. So filtration may be called as a one of the separation technique. It is not a synthetic thing or all that. It is a separation technique. It is a purification technique. Normally what happens, so whatever you want to filtrate or whatever you want to separate, now for the separation purpose you need a mixture. Now mixture may be of different kind. Suppose that liquid plus solid is there, so you call it as a fluid. Liquid plus solid, you call it as a fluid or suspension. Okay, liquid plus solid, you call it as a suspension, or it may be called as a fluid, but more specifically solid in the air is called as a fluid. Filtration is nothing but the separation of solid and separation of dispersed phase, separation of dispersed phase from the continuous phase, or separation of solid from liquid, or separation of solid from air. You, you may ask, so why there is need of separating solids from air? So you might be working in the your parenteral products. So there you need a cleanliness, you need a clean air. To obtain a clean air, you need a air purifiers. Okay, you need a high efficiency particulate air filters, HEPA filters. So HEPA filters are nothing but they are also type of special type of filters. Okay, so you need a clean air in the parenteral production. Okay, you need a parenteral working area. So for clean air, then if you want to obtain a product pure form, obtain a product in a pure form, so you need a filtration. So filtration may be regarded as a separation technique. Okay, now here you need 3-4 kind of material. So slurry, for example, solid in a liquid slurry. Then you need a filter medium. Okay, then okay, you need a filter medium, and you need a different kind of apparatus and factors. Suppose that you have slurry over here, liquid plus solid in this slurry. Now filter medium. So in the laboratory scale, you use filter paper, funnel and filter paper. So filter paper is nothing but your filter medium. Whatever slurry is there, whatever slurry you are pouring in the funnel, that is a mixture to be separated or to be filtrated. Okay, so that slurry has a solid particle and liquid. So in the filter medium, through a filter medium, so filter medium acts as a support. So filter medium acts as a support, and filter medium will have some kind of pores through which liquid only gets entry, liquid only gets entry. Okay, and solid will be retained on it. So that is nothing but the filtration. That's how there is a separation. So for the separation using filtration, filter medium plays important role. Remember, filter medium plays important role. Okay, whatever the solid particles are there which are written on the filter paper or filter medium, so the content that is written on the filter medium is known as a residue or cake. And whatever the liquid portion is there, that is being filtered and collected at the end, that is known as a filtrate. So whatever the cake or residue will remain over here is known as a residue or cake, and the whatever solvent or liquid that coming out of the this funnel is known as a filtrate. Okay, so remember this. Now the efficiency of filter medium, initially the rate of filtration will be slow. Okay, and after that the rate of filtration will be optimum. Initially rate of filtration will be initially rate of filtration will be high, and then rate of filtration will decrease because of formation of cake. जैसे आपने इनिशियली यहाँ पे पोर किया, जो स्लरी है मिक्सचर है, तो फिल्टर मीडियम जो है वो पूरा ओपन था तो उसके पोर्स भी है जो that is also open, and because of that filtration rate of filtration will be initially high. But as there is an accumulation of these solid particles, so these solid particles will clog the pores present in the filter medium, so the rate of filtration will decrease. So we'll see the different factors affecting on the filtration, types of filtration, mechanism of filtration, theory of filtration, all that. Don't worry, in the upcoming slide. So remember, this filtration process is it is a separation process. Okay, so for the filtration you need a slurry means solid in the your liquid or fluid, you can call it as a fluid. So but fluid is a more specific term when solid is dispersed in the air. Okay, so that is a fluid, but if solid is present in the liquid, so you can call it as a slurry or you can call it as a suspension. Now basically the filtration technique needs different. So this filter medium is very important. The solvent present in the slurry, its characteristics is again important factor for filtration. Then the solid particles which are present in the slurry, that means the nature of solid particle, the particle size and all that, that also affect the rate of filtration. Now filtration is nothing but the separation of solid from liquid, separation of solid from liquid or separation of solid from fluid by passing through a porous membrane that retains the solid particle and allows the liquid to pass. Now this is a definition of your filtration: separation of solid from fluid or separation of solid from liquid by passing through a porous membrane that retains the solid but allows the liquid. Okay, allows liquid to pass. Now this membrane, whatever membrane you are using, it is known as a filtration medium. It is known as a filtration medium or filter medium, or filtration medium. Now the term filtration itself is used when the solid content of your mixture or solid content of your slurry is more than 5% or more than 5% or 10%, 30%, etc. So filtration is the term when there is a solid content more than 5%. Okay, the term clarification is used. The term clarification is used when the solid content of your mixture or solid content of your slurry is less than 1%. ठीक है, अगर आपके स्लरी में, आपके फ्लूइड में, आपके सस्पेंशन में 1% से कम solid present है, in that time you call it as a clarification. Okay, remember this term, clarification means when when the solute concentration is less than 1% weight by volume, and at that time, so instead of using filtration term you have to use clarification term. Okay, इसके ऊपर भी फार्मासिस्ट एग्जाम में क्वेश्चन आ चुके हैं. So what is clarification? So when the solid content is less than 1% weight by weight, the filtration technique is known as ultrafiltration, then clarification, then filtration, HEPA. Like there was some kind of options like this. So answer was a clarification. Remember, clarification is the term when solid content is not exceeding 1% weight by weight. Okay. As I have told you, if you are working in the various kind of industry, so this filtration unit operation is very important. Okay, suppose that you have synthesized one compound in a lab also, so you need to isolate that compound, so you need a filtration technique. Okay, filtration process in a industry also, large scale industry also, so filtration is very important. Okay, so that is a purification technique, it is a separation technique of solid from fluid or solid from liquid. Now if you are working in the parental products, if you are working in the biological products, so at that time you need a cleanliness, you need a sterilization, you need a very clean air. Okay, so you need to filter the air. So HEPA filters, that is nothing but the high efficiency particulate air filters. So these kind of HEPA filters, they filters the air, they filter the air and purifies the air from the same I already told you. So air consists of various solid particles. So these HEPA filters will filter that. Even these HEPA filters has a very highly efficient filters. They are having 99.97% efficiency to remove the particles of 0.3 micron. So zero point 0.3 micron means they are very efficient, and whatever molds, whatever bacterial cell, जैसे fungal cell होता है, bacterial cell होता है, so most of them they are having a yeah, uh, they are having their cell in a range of 3 micron to 5 micron. So that's why these HEPA filters can remove even airborne infection or airborne contamination. So that's why they are providing you high purity airs. Okay, so that's why they are also filters. So to obtain a sterile air in the parenteral production area, you need a HEPA filters. Remember. Now in microbiology also you are using laminar airflow or laminar air benches. So in that air laminar air benches also HEPA filters are they are used, they are fitted. Okay, there are what is the mechanism of filtration? Okay, mechanism of filtration, again remember the types, mechanism of filtration. This is again a very important point. So how there is a filtration? So there may be either staining means it's like a similar to sieving. जैसे आप मॉर्निंग में चाय बनाते हो, तो चाय बनाने के बाद चाय को आप क्या करते हो, चाय को आप फिल्टर करते हो, ओके, बाय यूजिंग योर स्ट्रेन मतलब चाळणी. तो that is a similar kind of staining means similar to sieving. Large size particles, they cannot pass through a filter medium. Okay, in case of tea filtration you have a strainer over there, so that is a staining process. So removal of large particle your liquid, that is a staining by using a some kind of cloth or by using some kind of sieve, that is a staining. Okay, so it is one of the mechanism for filtration. Staining is mechanism for filtration. Then again there is another mechanism known as a impingement. So here in case of impingement, solid having momentum moves along with the path of streamline flow and strike or impinge into the filter medium. मतलब यहाँ पे वो फिल्टर मीडियम जो है वहाँ पे उसमें अटक जाता है स्ट्रीमलाइन फ्लो में. जैसे आप पाइपलाइन है, पाइपलाइन में एक फिल्टर यूज करेंगे तो क्या है, स्ट्रीम जैसे पाइपलाइन में फ्लो हो रहा है आपके वाटर का या फिर जो भी फ्लूइड है उसका, सो उसमें के जो सॉलिड पार्टिकल है वो अटक जा रहे हैं, इम्पिंग हो रहे हैं. सो सॉलिड हैविंग मोमेंटम मूव अलोंग विद द पाथ ऑफ स्ट्रीमलाइन फ्लो and strike or impinge with the filter medium. That is another mechanism of filtration, impingement. Okay, remember staining, impingement. Then another mechanism for filtration is entanglement. Entanglement, particles becomes entangled in a mass of fiber cloth of very fine or having hairy structure. जैसे filtration medium है for example आपका, ठीक है, जैसे वूल है आपका या फिर कॉटन है, सो कॉटन या वूल, सो in that case the solid particle will get entangled. So particle becomes entangled in the mass of fiber or cloth with a very fine hairy surface, that is nothing but the entanglement. Okay, then last one is attractive forces. So there may be attractive forces between the filter medium and solid particle, so that solid particle will retain on the filter medium as a result of attractive forces between particles and filter medium. So these are the four mechanism for filtration. Okay, so filtration के mechanism याद रखो, what are the different mechanism for filtration, उसका सिर्फ नाम याद रखो, बाकी क्या है exactly उसमें ये भी नहीं याद रखा तो भी चलेगा. At least you should remember the mechanism of filtration. कितना है, straining, then impingement, then entanglement, and then attractive process. Okay, so they may ask you a question like this: one of the following is not a mechanism involved in the unit process filtration. So they may give you these options, few of these options, and they may give another option which is not present in this. So they may give you option like straining, impingement, entanglement, and repulsive forces, or they may give example option like this. So you should be able to answer that question. Mechanism of filtration, these are the four mechanisms of straining, impingement, entanglement, and attractive forces. Now we'll see types of filtration. What are the different types of filtration? Basically there are two types of filtration. First one is known as surface filtration, and second one is known as a depth filtration. First one is known as surface filtration. It is also known as a screen filtration. Surface filtration, it is also known as a screen filtration, and second one is known as a depth filtration, or it is also known as a, it is mostly used for the clarification. Depth filtration is mostly used for the clarification, and third one is known as a cake filtration. So these are the types of filtration. So types of filtration. Okay, surface filtration, depth filtration. Surface filtration is also known as screen filtration. Depth filtration is also used for the clarification. And I have told you what do you mean by clarification. When the solid content of your slurry or solid content of your fluid is less than 1%, so instead of using filtration term, you have to use clarification. So what do you mean by? There are two types of filtration I have told you. So first one is a surface filtration or screen filtration, and second one is a depth filtration. So I will explain this using this diagram. You can see over this diagram types of filtration. So first one is a screen filtration or surface filtration, and second one is a your depth filtration. This is a demonstration of your surface filtration or screen filtration. So in this filtration, you use some filter medium which is having screen or some perforations. Okay, so because of these perforations, your solid particles will not get entry, and they will be collected on the screen, and liquid will be passed. Liquid will be allowed it. So screen filter with the direct passage of the carrier molecule. So that is nothing but the screen filtration or surface filtration. Now another filtration type is nothing but the depth filtration. डेप्थ फिल्ट्रेशन मीन्स व्हाट, कि जैसे मैंने बोला है कि आपको यहाँ पे आपने स्लरी डाल दिया, तो इनिशियली क्या होता है कि यहाँ पे जो मीडियम ऐसा है आपका जो फिल्ट्रेशन मीडियम है, तो उसके पोर्स होते हैं, उसमें छोटे छोटे पोर्स होंगे, ठीक है। वो पोर से क्या होगा, लिक्विड आपका नीचे जाएगा, ओके, सॉलिड पार्टिकल ऊपर रहेंगे। लेकिन इनिशियली क्या होता है कि इनिशियली उसमें फिल्ट्रेशन जो है वो रेट ऑफ फिल्ट्रेशन ज़्यादा होता है। बाद में क्या होता है कि यहाँ पे सॉलिड का एक लेयर जम जाता है, दैट इज नोन एज केक, दैट इज नोन एज केक, फिल्टर केक। जैसे ये फिल्टर केक जमा होता है, तो उसके बाद में भी फिल्ट्रेशन चालू रहता है, लेकिन कम रहता है, लेकिन फिल्ट्रेशन तो होता है। ओके, सो वेन एवर देर इज अ कलेक्शन ऑफ solid particle on the filter medium, so that oppose the filtration, that oppose the filtration process, that oppose, but still filtration is going on. Now liquid is moving through, moving through the pores present, or pores or capillaries which are formed between the particles of your cake. तो केक के पार्टिकल के बीच में जो कैपिलरी है, या फिर केक के पार्टिकल के बीच में जो चैनल है, so through that channel, so your liquid is moving, okay, and it is moving very slowly, that is known as a depth filtration. Okay, depth filter, greater the thickness of and more the porous liquid pathway, okay, tortuous pathway, more tortuous pathway. So here linearly your liquid is moving because there is a this screen, okay. So these particles, they are having more size as per the size of screen, that's why they are retained on the screen, that is known as screen filtration or surface filtration. Now in the depth filtration, as there is a accumulation of your solid particle layer over here on the screen, so whatever the liquid is, so that liquid is moving through a small capillaries present between the particle, or small channels present in between the particle, and that is not a linear flow, that is a tortuous flow, ठीक है। कैपिलरी कहाँ पे भी हो सकता है, ऐसा टेढ़ा मेढ़ा भी हो सकता है, जैसे यहाँ पे ऐसा कोई कैपिलरी ऐसा भी हो सकता है टेढ़ा मेढ़ा, so that is a tortuous liquid flow, okay. So these are the two types of filtration. First one is nothing but the your surface filtration, second one is nothing but the depth filtration. Are you getting or not? समझ रहा है? So we have seen this again. Now we'll see next. Okay. Now theories of filtration. Theories of filtration. Now theories of filtration. So what are the different things? Because these theories also very important. इसके ऊपर भी आपको क्वेश्चन 100% आ सकता है. What are the theories of filtration? Filtration एक बहुत ही सिंपल चैप्टर है आपको लगता है, लेकिन उसके जो theories है, उसका जो मैकेनिज्म है, उसके ऊपर क्वेश्चन आता है, उसके जो different types of filtration फिल्ट्रेशन यूटेंसिल्स, फिल्ट्रेशन ऑपरेटर्स है, उसके ऊपर क्वेश्चन आता है। नाउ थियरीज ऑफ फिल्ट्रेशन, व्हाट डू यू मीन बाय थियरी ऑफ फिल्ट्रेशन? सो रेट ऑफ फिल्ट्रेशन, द वेलोसिटी ऑफ फिल्ट्रेशन, velocity of filtration means the amount of liquid cleared per unit time. That is nothing but the rate of filtration or velocity of filtration. Now the velocity of filtration depends on the different factors. As I have told you, there are two types of filtration: surface filtration and cake filtration. Surface filtration and depth filtration. So there are two kind of filtration, and depending on that, so the velocity or movement of your liquid from your slurry, so that depends on the various factors. बहुत सारे फैक्टर्स है, उसके ऊपर डिपेंड करता है आपका फिल्ट्रेशन। जैसे जैसे मैंने बोला है कि सोल्यूट रिलेटेड फैक्टर्स, सोल्यूट रिलेटेड कौन से फैक्टर हो सकते हैं? जैसे आपका साइज ऑफ योर पार्टिकल, उसके बाद में पार्टिकल का नेचर, पार्टिकल शेप, अमाउंट ऑफ पार्टिकल कितना प्रेजेंट है। सो इफ यू हैव कॉन्सेंट्रेटेड स्लरी, बहुत ज़्यादा मतलब कॉन्सेंट्रेट 70% सॉलिड है उसमें और 30% वाटर है, सो फिल्ट्रेशन, द रेट ऑफ फिल्ट्रेशन विल बी स्लो। बट if your slurry has only 30% solid and 70% liquid, then obviously the rate of filtration will increase. So rate of filtration depends on the various factors. Now these factors they are explained by various scientists, and they comes under the theory of filtration. Okay, now the rate of filtration or the filtration rate or rate of filtration is equal to driving force divided by resistance. Driving force divided by resistance. So how filtration rate is given? Filtration rate is given by driving force divided by resistance. Driving force divided by resistance. Now what is the driving force? Driving force is nothing but the pressure differential. Pressure differential above the filtration medium and below the filtration medium. कि जैसे अपने फनेल में फिल्टर पेपर रखा है और नीचे बीकर रखा है और उसमें स्लरी डाल दिया, तो जो फनेल के ऊपर जो प्रेशर है और फनेल के नीचे जो प्रेशर है, वो डिफरेंस जितना ज़्यादा होगा उतना ज़्यादा फिल्ट्रेशन इफेक्टिवली होगा आपका, मतलब उतना ज़्यादा फिल्ट्रेशन रेट होगा। सो ड्राइविंग फोर्स इज नथिंग बट द डिफरेंस इन द फिल्ट्रेशन above difference in the pressure above the filter medium and below the filter medium. So difference in the pressure above the filter medium and below the filter medium divided by resistance. Okay, now what is meant by resistance? So your filter medium will resist the filtration. It is nothing but the support, so it will resist the filtration. So driving force divided by resistance is nothing but the filtration rate. And if you are not using any external pressure, so in that case driving force is nothing but the gravity. ठीक है, अगर आपने कोई प्रेशर वगैरह अप्लाई नहीं किया, अगर प्रेशर से स्लरी फीड नहीं किया या फिर नीचे फनेल के नीचे आपने वैक्यूम नहीं लगाया, सो इन दैट केस व्हाट इज द ड्राइविंग फोर्स? इन दैट केस ग्रेविटी इज द ड्राइविंग फोर्स। नाउ अगर आपने फनेल के नीचे अगर वैक्यूम लगा दिया, सो अगेन फिल्ट्रेशन विल बी इंक्रीज, द रेट ऑफ फिल्ट्रेशन विल बी इंक्रीज। ओके, सो याद रखो कि वैक्यूम अगर लगाया नीचे से below the filter medium, if you apply the vacuum, the rate of filtration will be increased. Or in another way, you can apply the pressure, or you can apply the pressure on funnel. तो जो स्लरी फीड करने का रेट जो प्रेशर से फीड करो वहाँ पे फिल्ट्रेशन रेट इंक्रीज हुई। सो फिल्ट्रेशन रेट इज इंक्रीज्ड बाय applying the pressure above the filter medium, decreasing the pressure below the filter medium. ये याद रखो। So either you can apply the pressure on filter medium by feeding the slurry forcefully or with the pressure, that can also increase the filtration rate, or you can decrease the pressure, or that means decreasing the pressure means you can that is increasing the pressure means positive pressure and decreasing pressure means negative pressure. So you can either feed the slurry with the positive pressure, that can also result in the increase in the filtration rate, or you can decrease the or you can apply the negative pressure below the filtration medium, so that again filtration rate will be increased. Okay, so filtration negative pressure means that is nothing but the vacuum or suction. आप कॉलेज में देखो सक्शन पंप होता है आपके इसमें फिल्ट्रेशन के लिए, तो नॉर्मली फिल्ट्रेशन जल्दी नहीं होता, लेकिन सक्शन पंप में एक कुछ सेकंड में आपका फिल्ट्रेशन हो जाता है। because of that. Now this theory of filtration involves this: filtration rate is nothing but the driving force divided by resistance. In case of no pressure, your gravity is nothing but the driving force. Now resistant for the moment, resistant for the moment of whom? Moment of your liquid. So resistant of the resistance for the moment of liquid, so that is calculated upstream pressure minus downstream pressure divided by length of capillaries. So कैपिलरी लेंथ ऑफ कैपिलरी इन केस ऑफ अगर आपके फिल्ट्रेशन मीडियम के ऊपर अगर केक फॉर्मेशन हो गया, सो इन दैट केस द लेंथ ऑफ कैपिलरी, ओके, द लेंथ ऑफ अपस्ट्रीम प्रेशर माइनस डाउनस्ट्रीम प्रेशर डिवाइडेड बाय लेंथ ऑफ कैपिलरी, दैट इज नथिंग बट दैट इज रेजिस्टेंस. ओके, so this theory we'll see one by one all the equations and all that. So I'm not going to explain these things in the detail. At least you should remember these things: what is filtration rate, what is the resistance. Okay, now first theory known as a Paucely's theory or Paucely's equation. Paucely's equation, okay, Paucely's equation. So according to this theory, the rate of filtration, मतलब क्या? This velocity of filtration is equal to, velocity मतलब rate of filtration. Okay, according to Paucely's theory, rate of filtration is equal to this pi delta p. Okay, pi into delta p, this pi into delta p into r raised to 4 divided by 8 into L into micro. Now I will explain these terms one by one. So what is meant by delta p? Delta p means pressure difference or pressure differential. मैंने जैसे मैंने बोला कि the pressure differential above the filter medium and below the filter medium. So that is the pressure differential. Now this is what is R. This R is nothing but the length, radius. Okay, radius of your capillary. In case of cake, so this Paucely's equation takes into consideration that there is a formation of cake. Now after the formation of cake, what will be the velocity of your filtration? So by taking this formation of cake or into consideration this Paucely's equation, velocity of filtration is equal to pressure differential into radius of your capillary divided by that L means length. L means length of your filtration medium, and this micro means viscosity of liquid being filtrated. So according to Paucely's equation, this will be the velocity of your filtration or rate of filtration is equal to this pi into delta p into r raised to 4 divided by 8 into L into micro. V is nothing but the flow rate. Flow rate means that is the rate of filtration. Delta P is nothing but the pressure differential across the bed. Bed means आपका filter medium. above उसके ऊपर कितना pressure नीचे. R means radius of capillary in the filter bed. L means thickness of जो cake. So whatever cake is built up on the filter medium by solid, the thickness of that is nothing but the L. And micro means viscosity of filtrate or liquid being filtrated. So that is the Paucely's equation. Now Paucely's equation or Paucely's experiment has considered the that thickness of cake. Now but they have not considered the permeability factor across the permeability factor across the your capillary. So Paucely's ने ये नहीं किया था कि permeability factor क्या है उसका, क्या ये कंसिडर नहीं किया हुआ. That's why डार्सी ने क्या किया, नहीं बोला कि मैं सही हूँ, डार्सी ने बोला मैं सही हूँ, ये थोड़ा सा उतना परफेक्ट नहीं. तो that's why Darcy equation came into picture. So according to Darcy's equation, velocity is equal to, velocity means rate of filtration is equal to Ka into delta P divided by micro into L. So what is the K? K is nothing but the permeability coefficient or permeability factor. Permeability factor of cake. Then A is nothing but the surface area of porous bed. Okay. Then delta P is nothing but the pressure differential, and micro is nothing but the viscosity of that filtered being filtered, and L is nothing but the thickness of your cake. Okay. Again, other terms are related to other terms are similar to Paucely's equation. Then ये कोजनी कैरमन ने बोला कि नहीं ये भी उतना करेक्ट नहीं है, ये दोनों भी उतना करेक्ट नहीं है, मैं ज़्यादा करेक्ट हूँ. ठीक है, इसने क्या बोला, कोजनी कैरमन इक्वेशन. According to कोजनी कैरमन equation, so the rate of filtration or the flow of liquid being filtrated, rate of filtration. is directly proportional to is equal to A into A divided by N S square into delta P divided by KL into epsilon divided by 1 minus epsilon square. तो ये इक्वेशन बोला. So what are these terms now? A means what? A means area, filtration area. N means ये तो viscosity. S square. So S means specific surface area of the particle. जो particle ऊपर केक फॉर्मेशन हो रहा है उसका specific surface area. डेल्टा पी मतलब प्रेशर डिफरेंशियल. ये तो आपको जो है. K means क्या? कोज़निक-एर्मन कांस्टेंट और परमेबिलिटी फैक्टर. Then L means thickness of your cake. Now ये terms है porosity. So this epsilon cube divided by 1 minus epsilon whole bracket square is a porosity. Okay. So कोज़निक-एर्मन equation has introduced this new term porosity. Porosity of cake कितना porous है उसके ऊपर डिपेंड है. जैसे केक अगर बहुत कॉम्पैक्ट बन गया है फिल्ट्रेशन मीडियम के ऊपर जो सॉलिड केक फॉर्म करता है, so if that cake is very compact and it will not have any capillaries, that means the rate of filtration will decrease. So if it is porous enough, then rate of filtration will increase. So that is the that term is taken into consideration by कोज़निक-एर्मन इक्वेशन. So आपके लिए क्या इंपॉर्टेंट है यहाँ पे? आपके लिए ये इंपॉर्टेंट है क्या? ये सिर्फ आपको इतना याद रखना है. कितना कि what are the different theories of filtration. Different theories of filtration आपको ये याद रखना है. Pauli's equation, Darcy's equation is related with the filtration. Then कोज़निक-एर्मन equation is related with the filtration. क्वेश्चन में ऐसा कुछ इस तरीके का क्वेश्चन आएगा कि one of the following theory is not related with the filtration. तो उसमें आपको ये 3 ऑप्शन देंगे और एक दूसरा कुछ ऑप्शन देंगे. ठीक है. Pauli's equation, Darcy equation, कोज़निक-एर्मन equation. These 3 equations are related with the theory of filtration. ठीक है. या फिर आपको इक्वेशन देंगे, ऐसा पूरा इक्वेशन देंगे और बोलेंगे इन द बिलो मेंशन्ड इक्वेशन दिस टर्म इज, एंड अकॉर्डिंग टू दिस इक्वेशन वी कैन एक्सप्लेन द डिफरेंट फैक्टर्स अफेक्टिंग ऑन द फिल्ट्रेशन. सो फर्स्ट वन इज दिस A surface area of your filtration medium. So as there is increase in the surface area of filtration medium, so there will be increase in the filtration rate because it is a directly proportional. ठीक है. V is directly proportional to A, inversely proportional to the this S square. S square means specific surface area of particle. Okay. Inversely proportional to the viscosity. जैसे लिक्विड जो है स्लरी में अगर बहुत ज़्यादा विस्कस है, उसका विस्कोसिटी ज़्यादा है, तो फिल्ट्रेशन क्या होगा? रेट ऑब्वियसली कम होगा बिकॉज दिस विस्कोसिटी टर्म इज इनवर्सली प्रोपोर्शनल. ओके. सो डिफरेंट फैक्टर्स अफेक्टिंग ऑन द filtration. So area of your filtration medium. So as the area of filtration medium increased, filtration rate of filtration will be increased. As the specific area of particles of the cake will increase, the filtration will be decreased. Okay, because it is inverse. Then viscosity of that liquid being filtered, if it is high, the rate of filtration will be decreased. Okay. Pressure differential. More is the pressure differential of the pressure differential at the cross section of your at the cross section of your filter medium. जैसे filter medium के ऊपर और नीचे जो pressure है उसमें बहुत ज़्यादा difference है. So if there is a high difference in the pressure, okay, across the filtration bed, so there is an increase in the filtration rate because pressure difference is directly proportional to the ये directly proportional. ऊपर वाले जो है वो directly proportional है, नीचे वाले जो है वो inversely proportional. So you can easily summarize the different factors affecting on the rate of filtration. Rate of filtration, it is directly proportional to the area of your filtration medium. इससे filtration medium बढ़ेगा, filtration का रेट भी बढ़ेगा. जैसे विस्कोसिटी बढ़ेगा तो filtration रेट का कम होगा. ठीक है. जैसे प्रेशर डिफरेंशियल बढ़ेगा वहाँ पे तो रेट ऑफ फिल्ट्रेशन भी बढ़ेगा. ठीक है. जैसे पोरोसिटी बढ़ेगा फिल्टर केक का, वैसे फिल्ट्रेशन रेट बढ़ेगा. जैसे ठीक है ऐसा. तो ऊपर वाले डायरेक्टली प्रोपोर्शनल, नीचे वाले इनवर्सली प्रोपोर्शनल. ओके. नाउ दिस कोज़निक-एर्मन इक्वेशन एक्सप्लेन्स यू व्हाट आर द डिफरेंट पॉसिबल फैक्टर्स दैट अफेक्ट द रेट ऑफ फिल्ट्रेशन. मैंने बोला है ना कि आपने अगर फोर्सफुली जैसे एक टर्म एक्सप्लेन करता हूँ डेल्टा पी. ठीक है. डेल्टा पी मीन्स प्रेशर डिफरेंशियल. डेल्टा पी मीन्स प्रेशर डिफरेंशियल. So pressure differential across the bed of your filtration medium. जैसे filtration medium के ऊपर से जैसे आप रेट ऑफ इंट्रोडक्शन, जैसे फोर्सफुली अगर आप स्लरी इंट्रोड्यूस कर रहे हो, दैट मीन्स देयर इज अ पॉजिटिव प्रेशर, सो प्रेशर डिफरेंशियल वहाँ पे ज़्यादा है, और बिलो द फिल्टर मीडियम इज लेस, so obviously rate of filtration will be increased. Okay, so either you can increase the rate of filtration by forcefully introducing the slurry, or you can decrease the pressure below the uh, filtration medium by using vacuum. So you can apply vacuum, there will be increase in the pressure, there will be increase in the filtration rate. If you apply pressure, if you introduce a slurry with pressure, again there will be increase in the rate of filtration. You can increase the surface area of filtration, so rate of filtration will be increased. As there is an increase in the thickness of your cake, जो केक फॉर्मेशन हो रहा है फिल्टर मीडियम के ऊपर, उसका थिकनेस जितना ज़्यादा होगा उतना रेट ऑफ फिल्ट्रेशन क्या होगा, कम होगा, बिकॉज रेट ऑफ फिल्ट्रेशन इज इनवर्सली प्रोपोर्शनल टू द थिकनेस ऑफ केक फॉर्मूला, इट इज डायरेक्टली प्रोपोर्शनल टू द पोरोसिटी ऑफ केक। जितना ज़्यादा केक बनेगा और अगर वो पोरस है तो उसका रेट बढ़ेगा, पोरोसिटी जितना बढ़ेगा उस केक का रेट ऑफ फिल्ट्रेशन बढ़ेगा। ठीक है, दीज आर द डिफरेंट फैक्टर्स अफेक्टिंग ऑन द योर रेट ऑफ फिल्ट्रेशन रेट। सो आर यू गेटिंग और नॉट, समझ रहा है नहीं समझ रहा है, बोलो मुझे। एग्जाम्पल्स ऑफ फिल्टर मीडिया, what are the different filter medium? Okay, so whatever the supports, whatever the porous support you are providing for filtration, okay, so mechanical support for filtration is given by this filter media। इसके ऊपर भी एक बार क्वेश्चन आया, तो उसमें फिल्टर मीडिया, फिल्टर एड, लिक्विड बीइंग फिल्टर और फनेल, ऐसा कुछ ऑप्शन थे। तो उसमें फिल्टर मीडिया का रोल क्या है? सो फिल्टर मीडिया इज नथिंग बट द, इट इज प्रोवाइडिंग द मैकेनिकल support as well as it is providing the it is providing it is providing the uh, your it is providing the capillary to filter, okay? So filter media may be of different type, like for example oven material such as felt or cloth। जैसे आपका फेल्ट और क्लॉथ मतलब जो आपका जैसे फेल्ट मतलब चालनी चालनी होता है, और क्लॉथ मतलब क्लॉथ इज नथिंग बट द ओवन थ्रेड्स ऑफ योर कॉटन। सो ओवन मटेरियल सच एज फेल्ट एंड क्लॉथ। परफोरेटेड शीट मतलब अगर कोई शीट है उसमें कुछ छेद है, सो दैट इज अ परफोरेटेड शीट ऑफ मेटल। जैसे आपने सीव देखा है, सीव इज अ परफोरेटेड शीट ऑफ मेटल। देन बेड ऑफ granular solid built upon a separating medium, bed of granular solid built upon a separating medium। जैसे केक मैंने बोला है कि जैसे आपने अगर कोई ये सैंड लिया, सैंड का एक लेयर बना के डाला आपके इसके ऊपर फिल्ट्रेशन मीडियम के ऊपर, और बाद में फिल्टर किया, क्या होगा? सैंड विल एक्ट एज अ प्री फिल्टर एंड दैट्स व्हाई it is known as a filter medium। Then fabricated porous solid, it is also one of the filter media। Then membrane filter media made up of a cellulose, sieve strip cartridge, sieve strip in silver nail, sieve strip cartridge, then depth type of cartridge, these are the used as a filter media। Now what is meant by filter aid? What is meant by filter aid? इसके ऊपर भी क्वेश्चन आ चुके हैं। व्हाट इज मीन बाय फिल्टर एड? सो फिल्टर एड मीन्स व्हाट? these are nothing but these are the substances, or these are the agent used in the filtration to increase the rate of filtration। okay, to increase the rate of filtration। aid मतलब क्या? aid मतलब हेल्प करने वाला। फिल्टर एड मतलब फिल्टर को हेल्प करने वाला। ठीक है, तो कौन हेल्प करता है फिल्टर को? फिल्टर एड्स। दैट मीन हेल्प मतलब क्या? they will increase the velocity of filtration or rate of filtration। And remember, question was like that, filter aids are used in the following concentration। So they are used in the 0 to 1%। okay, so filter aids are used in a 0 to 1% concentration only। okay, यहाँ पे एक बार फिर से बोलता हूँ मैं आपको, यहाँ पे याद रखो कि filter aids जो है they are used in the small concentration, that is 0 to 1%। filter aid they are used in a 0 to 1% weight by weight concentration। Examples of filter aid, for example, Kieselguhr, talc, charcoal, asbestos paper, asbestos, then paper pulp, then bentonite is a clay, okay, then fuller's earth, Kieselguhr, talc, charcoal, asbestos, paper pulp, bentonite, fuller's earth। So remember these filter aids। क्वेश्चन ऐसा भी आता है, ऑलरेडी आ चुका है, वन ऑफ द फॉलोइंग इज नॉट अ फिल्टर एड। तो तो याद रखो केसलगर, टाल्क, चारकोल, एस्बेस्टॉस, पेपर पल्प, पेंटोनाइट, fuller's earth. So these are used as a filter aid. They are used in this concentration 0 to 1%. So 0.5% of kesalgar is always effective as a filter aid. So that will increase the filtration rate of filtration by 5 times. So 5 times filtration rate increase कर सकता है केसल. Okay, just in a 0.5% concentration. Equipments for filtration. Equipments depending upon the application of external force. प्रेशर यहाँ पे अप्लाई कर रहे हैं उसके बेसिस पे कौन से फिल्ट्रेशन इक्विपमेंट्स. सो फर्स्ट वन इज द प्रेशर फिल्टर्स. उसके एग्जांपल क्या है? प्रेशर फिल्टर्स में कौन से फिल्टर्स है? प्रेशर फिल्टर्स, प्लेट एंड फ्रेम फिल्टर्स, प्लेट एंड फ्रेम फिल्टर्स, देन मेटा फिल्टर्स. सो दे आर बेस्ड अपॉन द एप्लीकेशन ऑफ एक्सटर्नल प्रेशर. वैक्यूम फिल्टर्स, उसमें एग्जांपल आता है आपका फिल्टर लीप. देन सेंट्रीफ्यूगल फिल्टर्स, तो उसमें आप सेंट्रीफ्यूगल फोर्स का इस्तेमाल करके you use centrifugal force over here, but this type of filter is not discussed in the chapter, so they will be discussed in the centrifugation chapter. So these are the different classes of your filters equipment used in the filtration. Now first one is a plate and frame filter, or it is also known as a plate and frame filter press. Remember इसके ऊपर क्वेश्चन आ चुका है GPAT 2018 में. So what is it? Plate and frame filter press. So it is constructed by number of plates and frames. So जो stainless steel का plates होता है और उसका ही frames होता है. Number of stainless steel plates and frames, they are parallelly arranged. They are arranged parallelly sequentially. So total number of plates and frames there will be 1080 plus उसके आगे 1080 plates and frames they are joined together in one of the following filter. That is a plate and frame filters. Question ऐसा था कि which of the following filter consists of a sequentially arrangement of plates and frames. और ऐसा ये भी था 1080. So this was question in GPAT 2019. So इसके related याद रखो. Number of plates and frames sequentially they are sequentially parallelly arranged so that there is an increase in the surface area for the filtration. So that is nothing but the plate and frame filters. Now next one is a filter leaf. Vacuum. Okay, vacuum air pressure is used in the filter leaf. So I will show the diagrams of different kind of filters after this slide. या इसके बाद में मैं filters different filters के diagram भी दिखा रहा हूँ आपको. But I'm not going to take the construction and working in the detail. Construction working detail में नहीं लेने वाले क्योंकि वो यूजफुल नहीं है उसके जीपैट के लिए. जीपैट के लिए क्या यूजफुल है ये जैसे मैं यहाँ पे समराइज किया और जो पॉइंट्स आगे बोलने वाले जीपैट के लिए, नाइपर के लिए, सब के लिए. फिल्टर लिप. इन दिस फिल्टर लिप वैक्यूम एयर प्रेशर इज यूज. तो वैक्यूम यूज किया जाता है. उसमें क्या रहेगा कि एक अरेंजमेंट रहेगा कि एक पाइप रहेगा और उसमें वैक्यूम का अरेंजमेंट रहेगा और वो पाइप दैट पाइप विल बी externally surrounded with the filter medium. Okay, and that filter leaf is dipped in the slurry which is being filtered. जो भी slurry आपको filter करना है तो वो slurry के जो ड्रम है या फिर जो भी है उसमें ही उसको डिप करना है और वैक्यूम लगाना है. तो ऑब्वियसली अंदर का जो लिक्विड है वो फिल्टर आउट हो जाएगा, सॉलिड बाहर रह जाएगा. सो दैट इज फिल्टर लिप. एंड रिमेंबर इसके ऊपर क्वेश्चन आया था स्वीटलैंड फिल्टर इज अ वेरिएंट ऑफ फिल्टर लिप. स्वीटलैंड फिल्टर इज अ वेरिएंट ऑफ फिल्टर लिप. तो इसके ऊपर भी क्वेश्चन आया. वेरिएंट ऑफ फिल्टर लिप इज नथिंग बट द स्वीटलैंड फिल्टर. वेरिएंट क्या होता है? सिंपल है कि फिल्टर लिप मतलब एक यूनिट हो गया. फिल्टर लिप मतलब एक यूनिट हो गया और ऐसे 2-4 यूनिट एक क्लोज्ड वेसल में जब करेंगे अपन अटैच तो उसको बोलेंगे स्वीटलैंड फिल्टर. नाउ नेक्स्ट वन इज अ मेटा फिल्टर्स. मेटा फिल्टर्स. Next one is a meta filters. So as the name indicates, meta means metal. So in this kind of filter, metal rings are there. So metal rings of 8 mm, 0.8 mm, metal rings of 0.8 mm contains semicircular perforated rings which are arranged as a nest. घरटे जैसा वो arrange किया जाता है to form a channel on edge. Meta filters can be used for clarification of syrup, filtration of injection solution, क्लैरिफिकेशन ऑफ इंसुलिन लीकर्स. इसके बाद में मैं बोलता हूँ आपको बस इतना याद रखना. नाउ नेक्स्ट टाइप ऑफ फिल्टर इज कार्ट्रिडेज फिल्टर. कार्ट्रिडेज फिल्टर. ए पोरस मेम्ब्रेन इन विच प्री फिल्टर्स एंड मेम्ब्रेन फिल्टर्स। तो याद रखो कार्ट्रिज फिल्टर में क्या है, प्री फिल्टर्स भी लगाए होते हैं और मेम्ब्रेन फिल्टर्स भी लगाए होते हैं। अब यहाँ पे प्री फिल्टर्स भी है, मेम्ब्रेन फिल्टर्स भी है, सो दे आर यूजफुल फॉर द ophthalmic and parental preparation, filtration of ophthalmic and parental preparation. Pre-filters and membrane filters, they are combined into a single unit. It is mainly used for the preparation of ophthalmic solution and your parental string discharge rotary filter. इसके बाद में एक फिल्टर आता है ड्रम फिल्टर, और ड्रम फिल्टर का एक वेरिएंट है, उसको बोलते हैं स्ट्रिंग डिस्चार्ज रोटरी filter. Is a string discharge rotary filter is a variant of your drum filter. Now filtration method is a choice for solution that contains chemically or physically unstable content. Membrane filters are also basic. Membrane filtration or membrane filters are the basic tool for microfiltration and ultrafiltration commonly used in the preparation of sterile solution. Membrane filters. Then the term clarification means if your slurry has a less than 1% solid content. Ultrafiltration मतलब क्या, वही the separation of liquid from solid by use of semi permeable membrane. It is known as ultrafiltration. Now जैसे filtration का rate increase करना, और there are another factor which can be used in the increasing the rate of filtration, जैसे temperature है. So if you increase the temperature of your that slurry, if you increase the temperature of that slurry, so rate of filtration will be increased. But how and why? See, your slurry consists of a liquid in and solid, so that particular liquid has some kind of viscosity, okay, and temperature is the inversely proportional to viscosity. जैसे temperature increase हो जाएगा, viscosity कम हो जाएगा, and you know that rate of filtration is inversely proportional to viscosity. जैसे viscosity कम हो जाएगा, rate of filtration बढ़ जाएगा. Viscosity अगर बढ़ गए तो rate of filtration कम होगा. So likewise there are different factors affecting on the filtration, so you can read from book. I have just explained a few of them. Now again uh, type of filter, then its principle and special comment. I have summarized one table. जितने भी आपके filters है वो एक टेबल में ला के रख दिया मैंने. Okay, so first one is known as a plate and frame filter or plate and frame filter press. So it is used when the slurry consists of 5% solid. 5% सॉलिड से ज़्यादा अगर है तो वो यूज़ नहीं कर सकते आप ये प्लेट एंड फ्लेम फिल्टर्स. सो मैकेनिज्म क्या है इसका? सो इट इज बेस्ड अपॉन द सरफेस फिल्ट्रेशन. द स्लरी एंटर्स इनटू द फ्रेम बाय प्रेशर and flows through the filter medium. The filtrate is collected into the plates and sent to the outlet. A number of plates and frames are arranged parallelly. Number of plates and frames are arranged parallelly so that surface area will be increased and rate of filtration will be also increased. So as there is increase in the surface area, a large volume of that slurry that can be processed at one time. यहाँ पे bloody हो गया, यहाँ पे bleeding slurry can be processed at the time. और special comment क्या है उसके ऊपर? So filter press or filter medium in the plate and frame filters. The filter medium is composed of asbestos, cellulose. So these two are the filter medium which are known as a bacteria-proof filter medium, particularly this asbestos and cellulose. So if the filter medium is used which is asbestos or cellulose, then this filter plate and frame filter can be used for the filtration of sterile solutions or sterile production. Then it is used for the collection of antitoxin, removal of protein precipitated from insulin liquor. से इंसुलिन जैसे आजकल जो है इंसुलिन जो है दैट इज फ्रॉम माइक्रोबियल ओरिजिन, कि इंसुलिन का माइक्रोबियल ओरिजिन से रिकमेंडेड टेक्नोलॉजी, उसमें बाकी प्रोटीन जो है दैट इज अ impurity. So to filter that pure insulin and to separate that protein, so this plate and frame filters are used. Again this is also used to remove the cell debris, cell growth from the fermentation. कोई अगर फर्मेंटेशन करके प्रोडक्ट बना रहे हो उसमें के प्रोडक्ट सेपरेट करने के लिए और सेल सेपरेट करने के लिए प्लेट एंड फ्रेम फिल्टर्स यूज करें. देन फिल्टर लीफ, सेकंड वन इज अ फिल्टर लीफ. सो इट इज यूज्ड when slurry containing again 5% of solid. It is also known as insert filters. इसमें क्या होता है कि this filter with longitudinal drainage screen covered with the filter cloth, उसमें क्या रहेगा एक लीफ जैसा स्ट्रक्चर है, उसमें लिप में कैसा होता है, एक बड़ी सी मिड रिब होती है और बाकी साइड में क्या है, मार्जिन वगैरह साइड में. तो मिड रिब will act as a drain and the lip will act as a filter medium. So that is apparatus with the longitudinal drainage screen covered with the filter cloth based upon the surface filtration and acts as a sieve strainer. Vacuum or pressure can be used to increase the rate of filtration. It is used for the batch process. It is a batch filter. Number of units can be connected in parallelly to increase the surface area and rate of filtration. Next one is a meta filters. It will act as a strainer, also based upon the surface filtration. And in this metal discs contain semicircular portion which are arranged as a nest to form a or and to form channel on edge. ये बाद में आपको समझ में आएगा जब दिखाऊंगा इसका images. Now remember, meta filters are used for clarification of syrup, filtration of injectables, clarification of insulin liquor, filtration of viscous liquor, and filtration of viscous liquid by application of pressure. Now next one is a cartridge filter. Cartridge filter. So cartridge मतलब क्या? Cartridge is nothing but the thin porous membrane in which pre-filtration and membrane filters are built up and they are joined together into a single unit. Filtration mechanism is nothing but the like a sieving. Then now remember this special comment. It is used for the filtration of parenteral and ophthalmic solution. कौन सा? Cartridge filter. आपको ये यहाँ पे ऐसा क्वेश्चन भी आ सकता है, मैच द फॉलोइंग डिफरेंट काइंड ऑफ फिल्टर्स विद देयर यूज, या फिर मैच द फॉलोइंग फिल्टर्स विद देयर मेन प्रिंसिपल. तो एक तो ये दोनों कॉलम में से मैच करने को बोलेंगे, ये कॉलम और ये कॉलम मैच करने के लिए बोलेंगे. ठीक है, तो आपको ये चार्ट जो है ये किसी बुक में नहीं है, इट इज मेड बाय मी ओनली. ये चार्ट इट इज अ हाइब्रिड चार्ट मेड बाय रीडिंग द कंटेंट इन द बुक. ठीक है, ऐसे चार्ट्स बुक में है और all kind of this such kind of charts you will find in the book. Now remember, by using cartridge filter you can filter 1 liter to 15 liters, 1000 to 15,000 liters solution per hour. तो cartridge filter जो है it is used in the parenteral and ophthalmic solution. It can filter 1000 to 15,000 liters solution per hour. Now next one is the drum filter. It is used when the slurry has a relatively high content of solid. Drum filters are used when slurry consists of 15 to 30% solid content. Now rotary drum filters. Rotary drum filters work on the principle of filtering the slurry through sieve-like mechanism, then rotating the drum surface under the condition of vacuum. Along with the filtration, other process is also there, like compression, drying, removal of filtered cake is also procedure. That is a filtration, washing and drying and removal of filtrate at one time in the drum filter. Production, it is used for the production of penicillins, collecting the calcium carbonate, starch and magnesium carbonate. इसका एक वेरिएंट होता है string discharge rotary filter. String discharge rotary filter, that is a variant of drum filter. Okay. Now this chart is again very important. Pore size and respective particle removed by membrane filters. Membrane filters कहाँ से बनते हैं? Membrane filters they are made of cellulose or asbestos. याद रखो, membrane filters they are made of cellulose or asbestos. ये already हो चुका है. Now there are variety of membrane filters already available according to the size. Okay, pore size in the micron, particle removed. So first one is a membrane filter of 0.2 micron. अगर 0.2 micron size का membrane filter है या फिर 0.22 micron size का membrane filter है, so that filter can remove all kind of bacteria. This was question in GPAT. So one of the following sized membrane filter can remove all forms of bacteria. और उसके नीचे ऑप्शन थे 0.2, 0.45, 0.8 माइक्रोन. सो 0.22 माइक्रोन और 0.2 माइक्रोन. ठीक है, याद रखो यहाँ पे 0.22 माइक्रोन और मेम्ब्रेन फिल्टर हैविंग पोर साइज ऑफ 0.22 माइक्रोन और 0.2 माइक्रोन that can remove all the forms of bacteria. ठीक है, वाइबल फॉर्म ऑफ बैक्टीरिया. बैक्टीरियल सेल को रिमूव कर सकता है कौन सा फिल्टर? ये फिल्टर. Membrane filter having pore size of 0.2 or 0.22 micron that can remove all bacteria. ये question GPAT में. Now again, membrane filter having pore size of 0.45 micron can remove all coliform group of bacteria. Membrane having 0.8 micron can remove all airborne particles. Membrane filter having pore size like 1.2 micron can remove all non-living particle considered dangerous in IV fluids. Membrane filter having zero point 0.5 micron membrane filter having 5 micron size can remove all significant cell from body fluid. All significant cells from body fluids. So this chart is again very important. You have to remember this chart. और it is a demonstration of your plate and flame filters. तो इसमें क्या रहेंगे ऐसे मेटेलिक प्लेट रहेंगे स्टील के या ब्रास के या ऐसे प्लेट रहेंगे यहाँ जिसके ऊपर आपका यहाँ पे क्या रहेगा यहाँ पे फिल्टर मीडियम रहेगा तो ये फिल्टर मीडियम they are vertically arranged parallelly they are arranged 1080 plates are arranged in a one unit so that is known as a plate and frame filters so इस तरीके से और यहाँ पे आउटलेट भी होता है फ्रेम में आउटलेट होता है these are arranged in a series parallelly they are arranged in a series you can see more okay so because of this arrangement the surface area is increased and it can be utilized so it can be also utilized for filtration of sterile product unless and until all the this utilities enclosed and it can be sterilized ये स्टरलाइल करो पहले और उसके बाद में आप स्टराइल फिल्ट्रेशन के लिए यूज कर सकते हैं दिस इज अ प्लेट एंड फ्रेम फिल्टर्स so if you want to read construction working you can read from the this pharmaceutical engineering by CVS Urman another filter is a filter leaf so for example this is a filter leaf okay this is nothing but the central central pipe or perforation okay that is known as a drainage canal और वो जो साइड पे ये जो है it is having filter medium that is a filter cloth उसके साइड पे filter cloth तो ये डीप करना है so whatever slurry you want to filter you just take this filter leaf deep in that and after dipping just apply vacuum okay यहाँ पे vacuum apply करो आप solid particles will remain on this the cake will form on the ये surface पे cake form हो जाएगा यहाँ और liquid will be sucked into in and it will be drained into filter so that is a filter leaf जिसे यहाँ पे demonstrate किया है filter leaf during filtration ठीक है तो ये केक यहाँ पे फॉर्म हो चुका है और जो भी सॉल्यूशन फिल्टर हुआ है ये यहाँ से निकल जाए now these filter leaf if they are arranged in a series if they are arranged in a one vessel okay and where the slurry is fed by pressure so slurry is fed by forcefully using pressure and if such filter leaf they are arranged in a parallel arrangement so that is a variant of filter leaf that is known as a Sweetland filter now next one is known as a cartridge filter the cartridge filter will be look like this so as I have told you cartridge filter will have pre-filter plus meta filter pre-filter plus membrane filter पहले pre-filter रहेगा तो उसमें बाद में membrane filter of 0.2 micron size का रहेगा so it can remove all form of bacteria so that's why it can be used for the this sterile filtration उसका ये assembly होता है ये पूरा यूनिट जैसे इसमें डाल दिया और लास्ट वन दिस इज एग्जांपल ऑफ ड्रम फिल्टर सो ये मूविंग होता है सो व्हाटएवर द स्लरी इज देयर ओके इट इज नोन एज अ स्लरी टब और स्लरी कंटेनर सो इन दैट यू हैव टू dip your drum filter and it used to operate okay so whatever slurry is there so यहाँ पे suctions रहेगा यहाँ पे आपका suction रहेगा vacuum so vacuum will attach this vacuum will suck all the solution and the solid residue जो है वो यहाँ पे अटैच हो जाएगा ये solid residue अब अंदर लिक्विड है so जैसे ये मूव हो जाएगा यहाँ तक आएगा तो यहाँ पे ड्राइंग भी होगा उसका so whatever the deposit are there whatever the cake is simultaneously solution is filtered cake is dried and cake is being removed over here by using scraper so इसमें दो तीन प्रोसेस simultaneously so filtration drying of cake and removal of cake ये washing of your cake is also there drying of cake washing of cake then removal of cake So this process simultaneously takes place in the drum filter. So this was regarding the filtration.